Welcome to my channel Simple Concepts by DJ. Today we are going to discuss about another problem which comes under the chapter Effects of Electric Current. I'll read out the problem. The problem states like this. A water heater is marked 1500 watts, 220 volts. If the voltage drops to 180 volts, calculate the power consumed by the heater. So here a water heater is being chosen and the values have been printed in the water heater nameplate, that is 1500 watt, which is nothing but the power consumption, and 220 volts is the value of the voltage in which the water heater operates. And now this is the nameplate details. Now they are telling if the voltage drops to 180 volts when the water heater is under operation, they have noticed that there is a drop in voltage from 220 volts to 180 volts. There is a drop in voltage. Now if there is a drop in voltage, they are asking us to find what is the power that would be consumed by the heater. Simple. So we need to take two set of values from this question. We need to extract the data and we need to work out the problem, right? For the first set of values, we have P1, denote power 1500 watts as power 1, that is P1. P1 equal to 1500 watts. 1500 watts. V1 is nothing but 220 volts. 220 volts. In the second stage, we have V2 has 180 volts, and we need to calculate the power, that is P2. P2 is the quantity that we need to calculate. So we have three set of values. So we need to figure out an equation such that it accommodates all the three values and one value, that is P2. With that equation, we can find the unknown quantity. So how we need to do? So I'll rub this one. So P1 equal to 1500 watts. V1 equal to 220 volts. V2 equal to 180 volts. They are asking us to find what is the value of P2. That is the power consumed by the heater when there is a drop in voltage level. So we know that power is nothing but power equal to, we know that power is equal to voltage into current. Voltage can be expressed as I into R. I into R into I. So this will become I squared into R. I squared into R, and I can be expressed as V divided by R the whole squared into R. So R gets cancelled. So I'll be left out with V squared divided by R. Right, V squared divided by R. This is the expression I'll be getting. So P equal to V squared divided by R. So the R value will not change. R is nothing but the resistance of the heater coil. Heater coil does not, the resistance value of the heater coil will not change. It remains as a constant. Okay. From the manufacturer point of view, whatever the manufacturer fixes the value of the resistance, the same resistance will be there. Okay. The resistance value will not change. Only the value of the power will change, value of voltage will change, value of current will change. But the resistance value which is attached, which is being inbuilt inside the heater, will not change. So we can keep it R as a constant term. So P equal to V squared divided by R. P equal to V squared divided by R. So we know P as P1. So instead of P, I am denoting it as P1. Instead of V, I am putting it as V1. Okay, so P1 equal to V1 squared divided by R. So I'll be getting P1 as 1500 watts is equal to V1 squared. V1 squared. Okay, V1 squared is nothing but 220 into 220. 220 into 220 divided by R. So which is nothing but, what is 220 into 220? 220 into 220, which is 48,400, which is equal to 48,400 divided by R, 1,500 here. So 0 gets cancelled. So I'll be left out with this equation. R equal to 484 divided by 15. So 484 divided by 15. 484 divided by 15, which is nothing but 32.26. 32.26 ohms. So this is the value of resistance. The value of the inbuilt resistance inside the water heater is nothing but 32.26 ohms. So the value of R has been calculated from this equation number 1. So the value of resistance is not needed, okay, but it is, that is not be a, that is what we are not going to find. We are not going to find the value of resistance, but we are going to find only the power. So for finding the power, that is secondary part, we need the value of resistance. So we have found out the value of resistance, okay. So the second thing will be P2 equal to, instead of P1 and V1, I'm going to substitute P2 and V2 instead of P1 and V1. So P2 equal to V2 squared. V2 squared divided by R. So now I'll be getting as P2, V2 squared. I know the value of V2 squared, which is 180 the whole square. 180 whole square divided by, what is the value of R? The value of R is nothing but 32.26. 32.26. So therefore, which is nothing but 180 the whole square. So 180, what is 180 whole square? 180 into 180. 180 into 180 will be 32,400, which is 32,400 divided by 32.26. So if I divide both the numbers, 32,400 divided by 32.26, the value will be 1004. The value is 1004 watts. Therefore, the value of P2 is 1004 watts. The value of P2 is 1004 watts. P2 is nothing but the power that has been developed by the water heater when there is a voltage drop of 180 volts. So this is the power, secondary power, that we need to find. The value of this power is nothing but 1004 watts. Thank you all.